right, so today we are looking at section 8.3. This is going to be geometric sequences and finding the sum of a finite geometric series. So looking at what a geometric sequence is. So here's what a geometric sequence would look like. Let's say that we start off a sub 1 equals 3 and r equals negative 2. If we start off with this situation, my first term is going to be 3. I multiply by negative 2. I multiply by negative 2. And I keep multiplying by negative 2. Okay, so that's what a geometric sequence looks like. We are multiplying by the same number rather than adding the same number every time. That's what creates a geometric sequence. To find that common ratio, what do you think we do? If r was negative 2 in this case, what do I do to find r? Yeah.
Divide 2 consecutive terms.
Yep. I like the way you said that. We're going to write that. Divide 2 consecutive terms. Second minus or divided by the first. Okay, so a geometric series just means that instead of having commas there, we actually have addition. So this would make it a geometric series. Okay, and that would be a finite geometric series. So we have 1, 2, 3, 4, 5. So this would be like the sum of the first 5 terms. So we're going to be looking at formulas for these situations, for a geometric sequence and for a geometric series. If we have a geometric sequence, the nth term, if we have a sub 1 as our first term and a common ratio of r, that is going to be given by this formula. You're going to have to know that. Memorize it. So it goes a sub n equals a sub 1 times r to the n minus 1. So back up to our example. My formula here would go a sub n equals a sub 1 times r to the n minus 1. So if I wanted to double check this, let's say I wanted to find my fifth term, I would do a sub 5 equals 3 times negative 2. 5 minus 1 is 4. What's negative 2 to the fourth power?
16.
And what's 16 times 3? 48, and that is what the fifth term is. Okay, so see how that formula does work. So they're just showing us another example. They're switching it around. First term is 2, common ratio is 3. That would be our formula. All right, so let's try a problem now. Find the fourth term of a geometric sequence with a first term of 3 and a common ratio of 1/2. All right, so first we want to write our rule for this, our nth term. Anybody know what that would be?
I have 3 times 1/2 to the n minus 1.
Good. Everybody understand why? A sub 1 is 3. Our common ratio is 1/2. And so now if I want to find the fourth term, I would say a sub 4 equals 3 times 1/2. 4 minus 1 is 3. I always have to do my exponents before I do multiplying because of PEMDAS. Exponents go down first. So what is 1/2 to the third? 1/8 times 3 would be 3/8. And that would be my fourth term. Now, if I were taking like the ACTs though, I wouldn't bother trying to think of this formula. If my first term is 3 and I'm multiplying by 1/2, 3 times 1/2 times another 1/2 times another 1/2. See how it really wasn't necessary to use that formula. Okay, but if they asked us for the 10th term, you know, it might get kind of difficult to just keep doing that. So sometimes it's beneficial to use the formula. All right, so next, the sum of a finite geometric series. As long as the common ratio isn't 1, and because that would force us to divide by 0, we can't have that. So the sum of the first n terms, as long as r is not 1, is going to be this. And this is another thing you're going to have to memorize. So it says to find the sum of the first 8 terms for this pattern. Find the sum of the first 8 terms. Well, that's written like this. The sum of the first 8 terms. What's a sub 1? 1/2. And then it's going to be 1 minus, what's our ratio? So it's going to be 2 to the n, which is 8, over 1 minus 2. So it's going to be 1/2 times 1 minus, do you know 2 to the 8th? I think it's 256. 256. Over negative 1. So it's going to be 1/2 times negative 255 over negative 1, which is just going to be 255 over 2, which is 122.5. Now, if that's on the calculator part, divide that, did I not have one left over? Yes, thank you, 127.5. If that's on the calculator part, then we could have just typed that in. Now, I do want to point out some things if you're going to use the calculator. When I type this in, I'm doing 1 divided by 2, and I'm going to have to be very careful with parentheses here. I'm going to have to do parentheses, and then this is going to have to be in parentheses, and this is going to have to be in parentheses too. You're going to have to use a lot of parentheses. So it's 1/2 times parentheses, parentheses, 1 minus 2 to the 8th, parentheses. Whoops, get out of there first. Okay, everybody see what I did there? Because I have to do 1/2 times this whole quantity, but I want this whole quantity to be divided by that whole quantity. And then it's divided by parentheses 1 minus 2, and then close the overall parentheses. I'll give you a minute to look at that. And then that will give us that answer. Okay? Now the other way we could do it would be to understand what the pattern is. So this pattern, I could do the sum as n goes from 1 to 8 of what's, to come up with my formula would be a sub 1, which is 1/2 times r, which is 2, to the n minus 1. Would that be right then? I would have to put this, no, that should work. All right, let's try this now. So we're going to go under math. X equals 1 to 8 of 0.5. I'm going to use 0.5 on this. Now, this gets tricky too because I needed to do the summation of this whole thing. So I'm, again, going to have to use extra parentheses. Times 2 raised to the x minus 1. Let's see if this works. I'm not positive. I think it should be good. Yeah. But you do have to be careful that you put that whole quantity in parentheses. Okay? All right, so a little bit tougher you can see with the geometric over the arithmetic. All right, let's go over here real quick and look at whether or not these sequences would be geometric. So one thing you have to think about is if it's geometric, we have to always have the same common ratio. So are we always looking at 12 divided by 4 is 3? Does it work here? Is that times 3? Is that times 3? Is that times 3? Yes. So we would say yes, r equals 3. All right, what about this one? No, you can see that real quick. What's this one actually? Yeah, this is arithmetic with t equals -5. Okay, what about this one? I'm going to need a calculator here. 7.8 divided by 1, whoops. So I want to see, is that, now I prefer just to multiply from here on out. So I'm going to do 7.8 times 6. Okay, that one's right. Times 6. Yeah, that's right. Times 6. Yeah, that's right. Yes. All right, what about here? What do we multiply? And sometimes instead of saying what's this divided by this, sometimes it's easier to say what do I multiply this by to get that? What do I multiply it by? -1/2. So if I do -1/2 again, does it work? -1/2 again, -1/2 again. Does it continue to work with -1/2? Yeah. All right. Write a rule for the nth term of the sequence, then find a sub 6. Okay, so do you remember what our formula is? Without looking, can you remember it? A sub n equals? Great. All right, so then we're going to substitute in. So we're going to finding the nth term rule is a sub n equals, plug in a sub 1, r is 3 to the n minus 1. That's called the rule. The rule means we have n, okay? When we're trying to find a sub 6, we're replacing n with 6. And 3 to the 5th, I think is 243, yeah, times 6. So 1458. All right, we're not going to do all these. Let's flip on down here to number 7. Looks a little more challenging. What are we multiplying by every time? 5 halves. So we know r has to be 5 halves. So let's write our formula. A sub n equals, a sub 1 is just r, or 1, I'm sorry, 1. R is 5 halves to the n minus 1. So that's going to be our rule. And then to find the 6th, it's just going to be 5 halves to the 5th. And if you're going to do this on your calculator, you need parentheses 5 divided by 2 to the 5th. But really, guys, all that means is 5 to the 5th over 2 to the 5th. I don't want to have that decimal answer, so I'm going to math frac, and we get 3125 over 32. 3,125 over 32. Okay, easy enough? All right, let's come over here to the next part. Write a rule for the nth term where a sub 8 equals 384 and r equals 2. Then graph the first 6 terms of the sequence. I'm not going to make you graph the first 6 terms of the sequence, but I want you to understand just for this one problem what the shape ends up being. So I am going to graph it for this one, but you don't have to when it tells you to on your homework. All right, so looking at this, I'm trying to find the rule. So a sub n equals a sub 1 times r to the n minus 1. You might know what we should do. Yeah.
You just first find a sub 1.
Okay, how are you going to find a sub 1?
Just divide by 289.
I don't know. Maybe.
You would plug in a sub 8, so it would be 384 equals a sub 1, 2 to the 8 minus 1.
Yeah, that's what I was thinking of to find it. So we're going to do 384 divided by 2 to the 7th, and that's going to tell us a sub 1. Is it 3? So now we know a sub 1 is 3. So now I can write my rule. A sub n equals 3 times 2 to the n minus 1. There's going to be my rule. Now, once I know what r is and I know a sub 1, I don't use the formula anymore. I just say, okay, a sub 1 is 3, r is 2, so times 2, times 2, times 2, times 2. 1, 2, 3, 4, 5, times 2. Okay, and again, I'm not even going to make you do 6 terms. You can do 4. I think it accomplishes the same thing. What they want you to see by graphing these, okay, so when n is 1, our answer is 3. And I'm going to have to make, I got to go up to 96. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So at 1, I've got 3, then I've got 6, then I've got 12, then I've got 24, then I've got 48, right around in there, and then I've got 96. So they want you to see what kind of function this ends up being. What kind of function does that end up being? It's exponential. So that's the only reason they make you graph those, is to see that it's an exponential function. The arithmetic ones, when you graph them, are always linear, right? So linear ones for arithmetic. All right. And then down here. So in exercises 10 and 11, write a rule for the nth term of the geometric sequence. This is a little bit tougher. This is where they're telling us a sub 3, so they're telling us the 3rd term and the 6th term. And we've got to come up with the rule. Any ideas on what we can do here? Yeah.
You could find a sub 1, find like an equation for a sub 3 and a sub 6, and then set them equal to each other.
That's good. That's the way I was doing it, and then I'll show you some other ways. If you guys can think of some ways, we'll go over that. But some other ways that would work. But yeah, she's right. So I'm going to say n equals 3. So if I do that, then I'm going to be having that, here's my formula, a sub n equals a sub 1 times r to the n minus 1. So a sub 3 is equal to 54. A sub 1 I don't know. R I don't know. N is 3, so 3 minus 1 is 2. So there's one formula I can get. But do you see how I have 2 variables in one equation? I can't solve that. But if I use the other information when n is 6, so what is a sub 6? 1458. I still don't know a sub 1. I still don't know r. But 6 minus 1 is 5. So what she was saying to do then is to solve this for a sub 1. So for my first equation, a sub 1 is going to be 54 over r squared. For my second equation, a sub 1 is going to be 1458 over r to the 5th. So what would I do if this is a sub 1 and this is a sub 1? Right, set them equal to each other. So I'm going to have 54 over r squared equals 1458 over r to the 5th. We cross multiply. We divide both sides by r squared. We get r cubed. We divide both sides by 1458 divided by 54, 27. And so r is going to be 3. Now, that's a really nice algebraic way of doing it. Can anyone think of a faster way? Go ahead.
Divide 1458 by 54.
Yes, that's always going to work. Okay? This is an algebraic reason as to why that works. So what he's saying is we divide the terms and then take the root of difference of n's, I guess we could say. Does that kind of make sense the way I'm saying that? Divide the two terms. These are the terms. We divide the terms, then take the root of the difference in the n. So in this case, our n is 6. Here our n is 3. Take that root. That will be a much faster way to find r. It's always going to work because we're always going to be cross-multiplying and getting that same kind of result. All right, so anyway, so now we know what r is. So now I could substitute in to find out what a sub 1 is. So 54 divided by 9 is 6. So a sub 1 is 6. So now I've got my rule. a sub n equals a sub 1 times r to the n minus 1. Okay? All right, so let's do it here now. So what do I do with my 2 over 125 and my negative 2? What do I do with those two values to find r? Divide them. So I have 2 over 125 divided by negative 2. Well, that's 2 over 125 times negative 1/2. So r, well, to start with then, that's going to give me negative 1 over 125. So I divided those two. Now what do I have to do with this? Take the, what's the difference in my n's? 3, so I have to take the cube root of that. So the cube root of negative 1 is negative 1. The cube root of 125 is 5. Now, I'm not big on memorizing things. Like, if you're not going to be able to remember this, I'd much rather you understand it algebraically and just go through it. Okay? So you got to be careful with that. So now we know what our r is. Here's r. Here's our, well, I can figure out what a sub 1 is just by substituting it in. I know a sub n is going to equal a sub 1 times r to the n minus 1. So here I've got a sub 2. So a sub 2 is negative 2. I want to find a sub 1. I know r is negative 1/5. Right here, n is 2, so that's just 1. I'm making this a little harder just to show you algebraically again. So what's a sub 1 going to be then? 10. Do you guys see why? We're multiplying by the reciprocal. So now we've got a sub 1. So now it's going to be a sub n equals a sub 1 times r to the n minus 1. Okay? So those are the tougher problems for sure with this type, is finding that rule when you're given these that are spread apart a little bit more. But also, guys, once I knew a sub 2, if I know I'm going to have an r value of negative 1/5, I could have just thought I'm going to go backwards. So I could have divided this by negative 1/5. Like, that's the more logical way rather than formula way. Okay, last one here. This one. I want you to add this one on instead of that one. Find the sum for k equals 0 to 6. All right, you can certainly use your calculator on this. But sometimes it's not so bad just to substitute in the numbers. What is anything to the 0 power? So my first number is 24 plus. Now I'm going to have negative 1/5. I'm going to plug in 1. So this was when I plugged in 0. I have to plug in 1. I have to plug in 2, 3, 4, 5, and 6. And I'm just showing this way because some people have a hard time plugging this into the calculator right. I'll show you next how to do that. But if you don't trust yourself with it, plug in 1. Negative 1/2 to the first is negative 1/2. That's going to be negative 12. Look at the pattern now. What are we doing every time? Just multiplying by negative 1/2. So this is going to be 6. That's going to be negative 3. That's going to be 3/2. That's going to be negative 3/4. That's going to be 3/8. And if I didn't feel comfortable putting this in, if I have one of the harder to work calculators, I might just want to add these up. Okay? Some of you can add these up. I have the easy calculator, so I'm just going to go ahead and plug this in. I go to my math. I go up to summation. I'm going to do x. You can actually use k's, guys. If you want to keep it exactly the same, I can go to alpha k. I can use k. Now, this is where you have to be careful, though. The parentheses here are not the correct way to put it in parentheses. It's going to have to be 24 times, and now parentheses again. Watch this. Negative 1/2, and that whole thing has to be to my k power. Oops. I would have stuck with x's actually, but, and now I'm going to close that parenthesis and cross my fingers and hope that that works. I may have needed another parenthesis there. Let's see what happens. darn it, that's what I thought. Okay, so what I needed was, see, this automatically ended my parentheses right there, and that's not where I wanted the K to be. I want the K on the inside. It's very picky with the way, I'm not even, I guess it'll do -1/2 to the, is that one gonna work? Is that right?
Yeah.
Okay. Yeah, that's nice. It automatically put that in parentheses for me, which is, you're gonna have to do it for yourself if you have one of the older calculators. It is really tough to do this with the older calculators. If I were you, I would bring one of my friends a treat and ask them to borrow their calculator for the day we have a quiz, because, yeah, I wouldn't want to mess with that sum sequence for stuff like this. All right, everybody got it? Pretty good? Okay.